Hey guys, today we are looking for the topic microscopy, its uses, the types of microscope, and some images that we visualize under the microscope. So, basically, microscope is a device which used to view objects like the bacteria and the microscopic objects, which means the objects which are unable to see with naked eyes. So such kind of objects are viewed with the help of microscope, and you can look for the part eyepiece, arm, nose piece, objective lenses, stage, diaphragm, condenser, coarse adjustment and fine adjustment, light source and a base. First of all, we are looking for the light microscope. So light microscope is also known as optical microscope. This is a very basic type, and they have a compound lens system, which means an eyepiece is there which have a particular power of 10x, and then a lower piece with a yellow line, and it also has the power of 10x, and a high power with a blue line with the power of 40x, and finally oil immersion with the power of 100x. So the eyepiece is multiplied with the power of the lenses to get the magnification, which means for low power 10 into 10 is 100. For high power it is 10 into 40, which means 400. And for oil immersion it is 10 into 10, no, it is 10 into 100, which is 1000. So this is the magnification we get. So each power should be multiplied with the eyepiece power, which is 10x, and we'll get the magnification. Okay. Likewise, magnification, resolving power is also important for a microscope. So what is resolving power? It is the ability of the lens system to distinguish two objects as separate rather than one, which means two or more different objects placed in the microscope stage should be visualized as each one of them. Nothing should be visualized as one. Each of the particles will be identified as separate particles. That power of microscope is known as resolution power of the microscope. So what does it depends upon? It depends upon the wavelength of the light we used. Also depend upon the, for optical microscope, the resolution power is 1.25, which is fixed for the optical or the light microscope. Next is the type of microscope. Basically, there are five types of microscope: light microscope, phase contrast microscope, dark field microscope, fluorescent microscope, and finally the electron microscope. These are the basic five types of microscope. So you can get questions on the different types of microscope for the examination. So every lab technician must know in detail about the microscope. So phase contrast microscope, it improves the contrast and makes the internal structure of the cells with more thickness and resolution power. So what's the difference of phase contrast microscope with that of light microscope? When rays of lights are passed through an object, they emerge in different phases. This is the basic difference. Means different phases are created with the help of the condenser and particular lens system, which is set up in the phase contrast microscope. So this is the difference. Two different kind of phases are created. So the special condenser and lens system converts the phase and intensity of light producing. So the change in phase creates change in contrast. This is the working principle. Okay. A light microscope can be converted into phase contrast by using a special condenser and objective lens system. So this is phase contrast microscope. You can visualize the change in the next picture. Okay. So you can visualize a special type of adjusting additional knob at the side of condenser. So you can just focus it or take screenshot and focus it. You can see the special type of condensed lens system here. So next is the dark field microscope. So here the reflected light has more importance. For phase contrast, the importance is the difference in phase is created and the contrast created. Here the reflected light is used instead of the transmitted light. That is a major difference. So a dark field condenser with circular stop is fitted with a light microscope. Here also change is made in the condenser. Okay, so no light reaches the eye of the visualizer unless and until the light is reflected from the object. So no straight lights are reached to the eyes of the observer, only reflected lights are reached. So what's the positivity of that? The object appears self-luminous. So here the object appears bright against the dark background. Okay, and the contrast gives an illusion of increased resolution. So here also contrast is made. Organisms like spirochetes, which are extremely slender bacteria, are visualized using dark field microscopy. So it is different from light microscope, where in light microscope the object is visualized as light, but here in the dark field microscopy the organism, the object appears self luminous against dark background. The background is dark, while in the light microscope the background is white. Here the background is dark. That's the main difference. The object appears self luminous. This is the picture of the dark field microscope. Here also a special type of condenser system is placed. You can notice the wired system of the condenser, which is connected to the diaphragm. So this is the difference between dark field microscope and light microscope. Okay. Next is fluorescent microscope. Fluorescence is the phenomenon in which an object is subjected to short wavelength and in return it emits higher wavelength of light. So what happens here is, in the fluorescent microscopy we use UV rays or the ultraviolet light rays, which is of shorter wavelength. It results in the emission of visible light with a higher wavelength. So what is happening here is the resolving power of the microscope is extended. Means 1.25, the resolving power of the light microscope is extended beyond that. Bacteria which are stained with the special dyes known as fluorescent dyes such as auromin, rhodomin become visible as brightly glowing objects in dark background. Here also the background is dark and the object is self-luminous here. Okay, and for the direct fluorescent microscopy, antigen detection is made, and for indirect method of fluorescent microscopy, antibodies are detected. So these are the techniques used in fluorescent microscopy. Smaller wavelength of light is used to produce larger wavelength of light, which extends the resolution power from 1.25 to above that. And you can look in the next figure of fluorescent microscope. This is the fluorescent microscope usually used. So the light source to provide the shorter wavelength is used in addition with the other microscope, and the right side is the bacteria which is visible in the fluorescent microscope. They appear self-luminous, bright against the dark background. This is the appearance of the bacteria in the fluorescent microscope. Okay, next we are looking for the electron microscope. Electron microscope is the most advanced type of microscope used now. So instead of light and the light sources, what we use here is beam of electrons. So the electron beam is focused by the electromagnets, which are opposite to that of lens. So The objects to be visualized are coated with the platinum like metals. So the objects are always coated with the platinum like metals to view under the electron microscope. They have the resolution highest of the resolution of 10,000 times than the ordinary light microscope. So the ultrastructural study of the organisms are made possible through the electron microscope. So they have the highest resolution power, so we can see the detailed structure of the organisms. This is the picture of electron microscope, and these are the pictures captured from the electron microscopes. The left one is the picture of virus and the right one is the picture of bacteria. So more attractive and more colorful, uh, more detailed structural version of the objects are visualized under the discovery of electron microscope. Okay, so please subscribe to this channel and like the videos. If you like the classes, you can comment your doubts or any other views from your perspective to improve my classes. Okay, thank you.